squared of 2 theta. So I'll write it, it looks as clear as possible, 2 theta there. D theta. That's our integral. I'm gonna trick you, Lee. I'm gonna trick you.
2 theta usually.
Is that?
It's 2 theta usually.
Hold on.
Isn't it the whole thing sine 2 theta?
Whole thing's what?
D would be the whole sine 2 theta.
Well, I mean, maybe I'm not going to trick you. You guys aren't even thinking. You think anything about this problem?
Oh, well, isn't it
It's even.
Oh,
Isn't that the last one we did?
All right, I got Raj at least. Good deal.
It's gonna be 0, right?
Oh, I got Cornejo. Good
Zero.
deal.
Zero.
No, it can't be
Even.
0 because
No,
you have
it's
to take the
even because
anti.
sine is odd and the exponent is even, right?
What's the question asking?
So if it's,
It's-
so it's just gonna be double the
You
end.
can't answer it if you don't
Isn't
have
that
the
a
question on there.
constant?
The question says, what is your name? You ready?
Roscoe Dash.
Ready, Susan? What are you saying, Justin? It is an odd.
Isn't sine odd? And
Sine's
then-
odd.
Yeah, and then since it's squared, that's even, so it's neither. So
What happens if you put an odd inside an even? We said when you add them together, it's nothing. What if you put one inside the other?
Well, it's an even, right?
That would it would make it.
Well, you're
odd, wouldn't
squaring
it?
it, so it's
No,
gonna be
make it
even.
even because
Odd,
what's
not
the-
even.
I thought it was even.
So it's just gonna be double the amount?
Because no,
It's
technically
even,
it's
yeah.
u squared, so it's even.
I don't know. All I know is that the limits are the same, so it equals 0.
No, it's going from negative
No, it
to
can't be.
positive.
I mean, if it were odd, they would be right.
It can't equal 0.
When it's even, you're not right.
It's 2 times the pi over 4.
Something like that.
Yeah.
Substitute pi over 4.
Well, hold on a second. Let's just write the rest up.
Yeah.
So you can do this. That's true. This isn't even function altogether, right?
Would you define area?
You're always finding error. Anytime it's a definite error, you're finding error.
So
We just don't draw the pictures all the time. That's
after
all.
you plug in.
Oh.
I can't plug anything yet. I've got to solve the integral. I've got to get the antiderivative. Right. Okay, so now what substitution do you want to make? 2? 2 theta?
Yeah.
Okay. U equals 2 theta. So then du is 2d theta. Yeah, I've got a 2 there. I wonder if they meant that on purpose. 2d theta. I wonder if they did that on purpose. So I should be able to write now integral of
Sine squared u d.
right. So now what are the new limits of integration now? So u is 2 theta.
0 and pi over 4 into theta.
Right? Just multiply the theta values through here. So 0 times 2 is 0. Pi on 4 times 2 is pi on 2. So we have our u values now. 0 to pi on 2. Okay.
Don't you delete the 2 on the side?
Hold on 1 second. What is it?
Where's the 2? Like, I know you took the rhythm of 2 d theta, but 2 isn't existing on our.
There it is.
Oh, it's on the outside.
Yeah, we got, yeah.
Wait, wouldn't it be 2 times 2 on that side?
No, I'm using up the 2, right? I'm using up the 2d theta and replacing it with the single du out here.
Oh, you cancel. 2's cancel out.
Correct.
The 2 and the d theta cancel out.
Yes, du substitutes for the entire
I didn't see the
2
2, yeah,
d theta. Yeah.
Okay.
If you hadn't doubled this from the beginning, it's not a big loss, right? Again, it's just a multiple constant. You would just divide it off and it would read 1/2, you know, negative pi on 2 to pi on 2.
Okay.
It wouldn't be a big loss. But, what are you going to do with this now? Sine squared, we're going to do sine squared. I don't think you know the answer. What do you say? Oh, let's see. Hold on a second. It's an interesting thought there. Oh, you're losing your touch, though. You're losing your touch. That?
No.
Or is it?
Sinus.
Sine cube?
Yeah,
Where? In addition to this?
no.
Just you're saying the answer is 1/3 sine cube? Like that?
Why do you think?
I would say neither one is that. Neither one is the answer. It's a little bit trickier.
Do you have to do chain? No, you can't do chain.
Let's make sure these are not the answer, because they could seem, especially this one, could seem really convincing. Why is this not the answer? Well, if you differentiate it, 3 comes down, right? If you did differentiate
Wait,
it,
it would be
d theta, what do you get? You get 1 cos squared theta negative sine theta. Is that right? That's what you get if you differentiate it. That's not our integrand. So now if you play it this way, the 3 comes down. What do you get? You get something similar, sine squared theta, but once you do chain rule on this, you're going to get a cos that comes out of this, which you don't have up there. So it's neither one of these exactly.
Just leave it as is.
Yeah, you're still in the towel. That's what you do when you go into a Brazilian Jiu-Jitsu match, right? You see that guy over there just like, whatever. Maybe next time.
Whatever.
You have to do another U substitution, like on the mini part.
So let's think about that. What if you do another U substitution? What if you do? What are you gonna let U be? Or W? What's W gonna be? You can do that. You could do a U substitution you need to do, right? Don't think this is out of the ordinary. You could do that.
Sine.
It looks like sine. That's the only composition I see. Sine is inside the square. But if W equals sine U, what's the derivative? Cos. I don't see a cos sitting around. You understand what I'm saying? Or not? Am I just talking?
Oh, I see what you're saying.
If you let W now equal sine U, which is a valid candidate at first, but dW is going to equal cos U du.
Can you do
You
that
can't
one?
account for you can, but then you're going to have 1 on cos U sitting inside here, and you've got W's and U's in the same expression. This is how you have to think when you're going through these problems. You're not sure where to go exactly. Right? Make sure you always get rid of all the U's and replace with complete W's. It's not going to happen in this case. Sine U will not work.
Is it sine squared? I mean sine squared over 2.
Sine squared over 2? Oh, you're saying for the answer?
Yeah, like 1.
No, because you'll still. You mean for the antiderivative?
Yeah.
No, because that will give you a sine cos as your derivative, which will not be the integrand. So what are you going to do now? You guys are out of suggestions. But it has to be within your repertoire, otherwise they wouldn't give it to you. You must have the knowledge and the intellect to put together to figure out what to do next. Otherwise it would be a homework problem. Yeah.
Can the original U be sine 2 theta?
You're running the same problem. When you differentiate, you're going to get a cos 2 theta, which you don't have in the expression. It's really the same issue as what we're saying here. It would be the same scenario.
Did you use a trig?
Trig identity?
Yeah, I mean, that
What'd you
would
say,
be
Lou?
good.
What's the U going to be? That's what we were suggesting. We were playing around with that. If W is sine U, you're always going to have a cos U come out. There's no cos U floating around inside your integrand. Would be the problem.
Can you make sine U?
Say it one more time.
Can you make sine U equal to another number?
Equal to another number?
Another
Variable?
Yeah.
That is what we did. See? W is sine U. We were playing around with this idea here. Maybe this will work. But then the derivative has cos in it. And you don't have a cos in here anywhere. You know what I'm saying?
Yeah, like 1 minus cos.
1 minus what?
Other 1 minus cos square.
That's true. This is the same as 1 minus cos squared. But once you have 1 minus cos squared, you're going to take the antiderivative of cos squared. And you run into the same basic structure, right? If you let U be cos, then du is sine, and you don't have a sine in that expression anymore. So let me suggest something else. Sine squared